All right, so this is question 4. So it says Alma and Blanca are playing a game where they roll a pair of fair 6-sided dice and try to predict the outcomes. Alma thinks that the probability of rolling the same number on both dice is greater than the probability of rolling numbers that add up to at least 10. Blanca disagrees. She thinks that the two probabilities are equal. So based on the sample space of the possible outcomes listed below, who's correct, Alma or Blanca? So Alma believes that the probability of rolling the same number on both dice is greater than the probability of rolling numbers that add up to at least 10. Okay, so it gives me a diagram of all the dice and all the possibilities. So what I'm going to do is I'm going to count the number. I'm going to count the number of times that a dice is rolled, and if the probabilities are, she thinks that the probability of rolling the same number of both dice. Okay, so I'm going to count the number of possibilities where the roll is the same number on both dice. So that's going to be double. So that's going to be 1 and 1, 2 and 2, 3 and 3, so forth. So if we look at this, the same number on both die, so that's 1 and 1, so that's 1 and 1, 2 and 2, 3 and 3, 4 and 4, 5 and 5, and 6 and 6. So that's 1, 2, 3, 4, 5, 6. So that's 6 out of 36 possibilities, that outcome. So because we're timesing by 6, so 6 times 6 is 36. So that is, Elmo thinks that the probability of rolling the same number on both dice is greater than the probability of rolling numbers that add up to at least 10. So that's Alma's assumption, and I don't know, Alma. We'll see. So Blanca disagrees. She thinks that the two probabilities, that then rolling the number. So Alma thinks that the probability of rolling the same number on both dice is greater than the probability of rolling numbers that add up to at least 10. So when she says at least 10, that to me says that they're not wanting to roll only to 10, they want to roll up to 10 and then also 11 and 12 because it says at least 10. So our options, we can also include rolls when dice equal 11 or 12. So Blanca thinks that the two probabilities are equal, so we're going to find out now. So I'm going to go through each of these, and I'm going to count how many rolls there are that add up to at least 10. So 10, 11, and 12. So going through, so we have 7 here, we have 5, 6, 7, we have 6, 7, 8, we have 5, 6, 7, 8, we have 6, 7, 8, 9. That's almost there. So now we have, all right, so we're in our 4th row of dice here. So I think we're going to start hitting 10. So now we have 5 and 4. So 5 and 4 equal 9. So we're not quite there. So 6 and 4. So that's one option. So 6 and 4 equal 10. So I'm going to mark that down as 1. So 6 and 4. And then we also have 5 and 5, which is another 10. We also have 5 and 4 is 9, so we're not going to include that one. We also have 6 and 5, which equals 11. So that we can write down 6 and 5. We also have another 4 and 6. So instead of 6 and 4, we have 4 and 6, which would make sense, but equaling to 10. So 4 plus 6. And then we have 6 and 5, which is another 11. And we also have 6 and 6, which is 12. So we have 6 plus 6. So I just want to make sure that if I count 6 and 5 and then 5 and 6, that those are okay if I count those doubly because you're rolling the same dice and the same numbers are appearing, however, the number appears on a different dice each time. So I'm going to go ahead and say that there are 1, 2, 3, 4, 5, 6 different outcomes for rolling a number that adds up to at least 10. So if we look back on Alma's probability, so actually we're gonna have, so Blanca is correct in this case where there are 6 chances of rolling a number at least that adds up to at least 10, as well as there's a 6 in 36 chance, so the same as the at least 10 option, of rolling a double-sided dice, or a dice that reads the same number. So I'm going to say that Blanca is correct. I'm going to check that. And it's correct. Perfect. So I'm going to show my summary. So I got 100%, which is great. Awesome. So that was it.